Hi everyone. Today we're going to be looking at adding and subtracting terms. So remembering a term is the combination of a coefficient and a variable. Okay. Now, to add and subtract terms, we first need to understand the difference between like terms and unlike terms. If two terms are like, they can be added together, no problem. But if two terms are unlike, which we're going to go through, they can't be added together at all. Okay, it can be something that's very easy to confuse in algebra, but it's just something you really need to get a hold of. So, like terms contain exactly the same pronumerals. Now, I mean the exact same. So, if I look at this first column of these terms here, we have 2x and 5x. So, they've got exactly the same pronumerals, is what we're looking at. Okay, same with negative 12a and 7a. They both just have the a. Now looking at the next one, we've got 5ab and 6ba. They do still have the same pronumerals, even though they're not in the same order, they're still the exact same pronumerals. So these two are like terms. Then for that last one, we've got x squared and 3x squared. They've got the same variable in the same power. That's another thing we really have to keep in mind, is that they also have the same power, if there is one. Okay? So down that unlike column, we can see we've got 3x and 5y, which are definitely not the same variable. 11d and 4c, once again, not the same variable. We've got x squared and x, so even though we've got the same variable, they are not the same power. Okay, so they need to still have the same power. And then we've got negative 8ab and 5a. This one here has no b, so they are not like terms. Pause the video here and have a go at just classifying these ones as like or unlike, and if they're unlike, try and give a reason as to why. This first one here, they are like terms, they both have x. For this second one, they are unlike because that second one has no p. Okay. That third one there, they are like, even though the C and the D are in a different order. And then that fourth one, it can be a bit tricky to read, but they are unlike because we have x squared and then y on the first one, but the second one has x and y squared, so they are not the same power. Okay. Once you're a master at this is when you can then move on to adding and subtracting. Okay. Like before, I like to whip out my highlighters just to color code any terms that I see that are the same, especially when there's multiple in the same question. When we add and subtract like terms, this is something we call simplification, okay? So the question could say simplify the following by collecting like terms. If they are the same, you kind of have to think of it as I have, if it was 4x and 5y, I have 4 x's on a shelf and I have 5 y's on a shelf, but I can't call that 9xy because xy is something different, okay? But if, let's say, I had 5 a's and 3 a's on a shelf, I could put them together and I've got 8 a's, okay? So looking at this first one here, I've got 13 u's on a shelf, whatever that u might be, and I take away 7 of them, I'm going to end up with 6 u's left over, okay? Now, look, this one here is missing a sign, but we're going to make that a plus C. I'm going to have a look that I've got my 3b and 4b together here are like terms, and that my C and my 5C are also like terms, okay? So 3b plus 4b would give me 7b, and then C, which is, remember, 1C, plus 5C would give me 6C, okay? Looking at this next one here, my variables are a bit jumbled up, so I have to kind of go look for them. I've got 7x here, and then we've got minus 11x. So be very careful of that minus. That belongs to the 11x. Then I'm going to move on to here. I've got minus 5y plus 12y. So I'm going to rewrite these so that those variables are together. And then that way we can do what we did above. Okay, remembering those minuses belong to the term that comes after. I've got 7x minus 11x. That's going to give me negative 4x. So it's almost like I've got 7x's and someone tells me I owe them 11. I'm kind of 4x's in debt. It's a bit weird to get around the whole variable thing. Then I've got negative 5y and I'm adding on 12y's, I've got 7y. So it's still the same as your usual number stuff. Now for this last one here, it is a bit tricky just because there's so many powers and everything going on, but you do just kind of have to read through. Here I've got 4uv squared. So I've got a u with no power and then a v with power of 2. So I'm going to look for another term that's got a v with a power of 2 and a u with no power. That second one there, the u's got a power of 2, so we know that they are unlike terms. Looking at this third one here though, we can see that the v has a power of 2 and the u has a power of 1. So that's going to become negative 11v squared u. They're going to be two of our like terms. Then for our other one, just to double check them, because we might not always give you terms that go together, this one's got a u to the power of 2 and a v with no power. And this one here also has a u to the power of 2 and a v with no power. So I'm now going to rewrite this as 4uv squared minus 11, and I'm going to swap the u and the v squared around because I can do that. Remember, the order doesn't matter. And then I've got minus 7u squared v, and then once again I'm going to swap the u squared and the v around. So I've got 4uv squared minus 11uv squared would give me 7 of those, or negative 7 of those, sorry. And then I've got negative 7u squared v, remembering that the negative belongs to the term after it. Minus 13 of them will give me minus 20u squared v. Pause the video here and have a go at the right-hand side, and I'll go through it. Looking at this first one, we've got 7ab plus 2ab. That's just going to give me 9ab because they are like terms. This next one here, I'm going to go hunting for those like terms. I've got 10a and negative 2a, and then I've got 3b and 4b. So that's just going to give me 10a minus 2a plus 3b plus 4b, which is going to be 8a plus 7b. Now for this next one, I'm not going to do any reordering. I'm just going to be color coding, okay? We have 5uv, that like term there is plus 4uv, and then I've got 12v minus 12v. This is going to give me 9uv plus 0v, and if we've got 0 of something, we don't have to write that because it's 0. It's not going to be necessary. It's not really there. So we can just write that as 9uv. Then for this last one, once again, I'm going to go for a look through. I've got CDE, ECD, and CED. Even though they're a different order, they're still the same variables involved. Then I've got 5ED and 11DE, and then my little negative 8DC is by itself, so it's not going to have anything affect it. So I've got 3 plus 5 plus 2 would give me 10CDE. I like to write them in alphabetical order. Then I've got 16ED, take away 8DC.